Hello, everyone. Welcome to today's webinar on rural road design using RoadEng. Today, we're going to be focusing on rural road infrastructure development, particularly focused on West Africa. My name is Erin. I'm the Business Development Manager here at Softree, and I'm going to be your host for today's webinar. Let's get started and let's talk a little bit more about rural road design using RoadEng. Our webinar agenda for the next hour, we're going to start with a little bit of an introduction to both Softree Technical Systems, so that's the company I work for, as well as KeyCam Technologies. They are our partner in West Africa. We'll discuss the role of rural roads and the critical role they play, I should say, and the role that RoadEng can also play in helping support that. We'll discuss some different applicable project types, and then we're going to move into two different software demonstrations. The first of which will feature total station data from a project in West Africa, and then the second will go with a little bit of a larger data set to give you a sense of the software there. Following that, hopefully you've got a little bit of time left for Q&A. So that's our agenda for the next hour. So we're going to start, as I said, with a little bit of an introduction. And we'll start with Softree. So Softree is a civil engineering software company. We are based in Vancouver, Canada. That's where I'm dialing in from this morning at the beautiful hour of 6:30 in the morning. We were founded actually quite a long time ago, which anytime when you've got longevity in tech, it's obviously something is working well. So we founded in 1989, and we have focused our software on engineering and planning as opposed to drafting, and really keeping it within a very core vertical of resource roads and rural roads. So all the content we're going to discuss here today really centered and focused around rural roads. Joining us on the call today, it's not just myself. I've got a couple folks with me. First and foremost, a familiar voice to those of you who attend our webinars. I've got Matthew Dickey. He is our lead webinar presenter, as well as our training manager. So Matthew is here on the call today, as well as I'm joined by our partner from KeyCam Technologies, Bonnie. He is the vice chairman, and he represents a lot of local expertise connecting Softree's technology to clients in West Africa. And with that, I'd actually like to turn it over to Bonnie for a moment just to introduce KeyCam Technologies, as well as some of the different supports that he provides locally.
Yeah, thank you very much, Erin. I appreciate it so much. Good afternoon, everyone. Our distinguished participants and industry professionals. My name is Bonnie Mikwe, just like Erin has pointed out. I'm the Vice Chairman of KeyCam Technologies. We are an end-to-end IT organization with expertise around 4 major domains, as it were: hardware, software, cybersecurity, and consulting and training services. On the software side, that's where we have a relationship with Softree, and we have expertise in terms of local support, which we provide training, and we have clients across not just Nigeria, but across the West African belt. We also organize local workshops and demos. And obviously, we are doing this as our first major webinar with Softree because we understand the challenges in the country. We understand the issues around infrastructure development, by both states, federal government, and local government. But however, especially around road connectivity, in order to open the communities, we discovered that quite a lot of challenges local contractors, meet, as well as the government agencies also supervising this, making sure that the right, design is done, cost effectively, and also ensuring some level of sustainability. So we believe that we are open to work with any of the local, state, and federal government agencies, including contractors, to these agencies or to government, as well as local partners who are also ready to work with us in delivering the software solution across the breadth of West Africa. So once again, we welcome you to this event, and please feel free, let it be as interactive as possible. And at the end of the day, if they are at the end of the event, if there are needs for additional focused, webinar or sessions, be rest assured that Kikam and Softtree are available to do that. Thank you.
Absolutely. Thank you, Bonnie. And Bonnie kind of touched on a really key piece there. That rural roads are critical. And I think one of the words that you mentioned was connectivity. And given the fact that over 60% of the population in West Africa, and to be honest, that number cannot be extended globally almost, living in rural areas, rural roads are providing this essential connectivity, this essential access to communities, to essential services. And access is more than just a road to be able to get to someone's community. It's not just connecting the residents, it's also potentially connecting tourists, connecting to resources, whether that be mining or otherwise, as well as being able to get that connection to markets, to schools, to healthcare, to ports, to manufacturing facilities. That connection is key. And rural roads really do have a whole bunch of secondary benefits as well. In emergencies, they act as evacuation routes. In wooded and forested areas, rural roads can act as fire breaks with our changing climate and the increased amount of fire that we're unfortunately facing. Rural roads promote economic growth and make it easier to connect to other infrastructure, whether that be internet, telephone, power. And they also make it easier to start to develop new industries and new resources in the mining and energy sectors. Now, rural roads are really important, but the design of the rural road is also really important. Poorly designed and constructed rural roads really do end to increase transportation costs. And that is both in a dollar sense as well as in a time sense. And with poor roads, you tend to see reduced economic activities and economic opportunities for the communities that they're connecting to, and limited access to those essential services. Well-designed roads and well-constructed roads, we got to put those together because they are part and parcel. They really do have this opportunity to improve local economies, minimizing surprises that can happen during construction, minimizing construction costs themselves, minimizing transportation costs, the time it takes to travel between places, and design really can help ensure that roads meet the end user's needs and perform well over their lifetime. A well-designed and constructed road costs less to maintain. Now, ultimately, the design side of it is really just a plan, but it's the plan that sets the goalposts as well as the expectations for the construction crews to be able to bring that design to life. So, well-designed roads, critical component with well-built and well-constructed roads. So again, they go hand in hand. But unfortunately, rural road design has some challenges when it comes to that design side. So in order to get a well-designed and well-built rural road, design software most often plays a role. It's very difficult to build, design and build a perfect road if you're not being able to evaluate it in sort of a greater context. So design software, really important role, but it too comes with its own set of challenges. First and foremost, working on a design software is time consuming. The actual design process itself and how long it takes to design on the computer becomes a barrier to doing design. Some folks think, oh, it'd be so much easier if we just took our construction equipment, put some stakes or some flags on the trees or on the ground and constructed the road without actually properly designing it. So that time investment into design is a barrier. Furthermore, complexity. Software especially design and civil engineering software, tends to include a lot more functions than are actually necessary for a rural road. It's the same software that you could design a highway interchange with, and it offers a lot of more complexity than is needed. With this complexity, of course, comes a very steep learning curve. Operating the software then becomes a barrier to use, as formal training invested over months and even years really becomes one of the prerequisites in order to operate it properly. And the last one, and I think this one is for me is probably one of the most important, is that the functionality in design software tends to focus more on that drafting side and not engineering. And as rural roads face, and particularly in places like West Africa, where you have, periods of very intense rainfall, and need to account for what the water is doing and what the terrain is doing and what different soil types and ground types are available. Being able to focus on those sort of more engineering elements is really important, and that has been a challenge in most design platforms. So we feel that addressing these challenges, requires a different approach. And RoadEng has kind of been doing its own different way of design, for about 36 years now. And we actually do think this is where it can help. And I'll talk through a case study in a few moments from a client of ours. But by doing something slightly different in a simpler way, you can get some pretty awesome results. So RoadEng itself is a design software, but it's not built for everything. It is very specifically built for rural roads and linear infrastructure. It integrates 2D and 3D design environments, allowing users to really easily import their survey data, adjust their alignments, get their volumes, and be able to communicate construction plans. It also has some tools that can help drive some efficiency and reduce that manual effort, especially when it comes to, say, automating the calculation of the vertical profile, automating calculations for earthworks and earthwork balancing. So a lot of streamlining that can enable faster iterations and better decision making while maintaining precision and efficiency. So some kind of key, say, ways that we reduce some of those barriers. In particular, the software itself is quite easy to learn. Over 90% of the users actually do not require any formal training. And someone like myself, who's the business development manager here at Softree, I can operate our software actually quite successfully. So that, is a testament to its ease of use. It works with nearly all data formats, and in particular is quite successful with large resolution ones. It's got some key functions, again, as I mentioned, to help improve that sort of design process. Earthwork optimizations, tools for managing drainage and helping you understand the impact that water is going to have in your design, and that ability to instantaneously see and understand the design changes. I've got a little video I should have been playing here. Yes, just to give you a sense of 3D. So you have really dynamic, easy to use software, but you can produce some great visual outputs as well. So RoadEng, of course, great for rural gravel roads, works on a whole bunch of other project types as well, though, whether that is sort of more of a highway, complicated terrain, renewable energy projects, as well as, a widening milling overlay projects. And as I mentioned, it can also not just be roads. And I wanted to take a second to highlight some pretty incredible work actually being done from a client of ours. This is the local government engineering department in Bangladesh. And I know today's seminar is about roads, but I wanted to share this other project type and with it their success. So canals, essentially upside down roads from a cross-section perspective, are really another critical piece of rural infrastructure, particularly in Bangladesh. So LGED created a project, the Improvement of Ponds Canals Across the Country Project, or IPCP for short. And they were really looking to revitalize thousands of kilometers of canals and thousands of ponds. in order to, improve agriculture and improve access to their constituents. So in the end, the IPCP project took a few years, and they were able to design and revitalize over 2,000 kilometers of canals using RoadEng, as well as over 5,000 ponds. The software, helped to facilitate engineering estimates, detailed design, and data analysis. And this design at this scale in a rural setting, and I must say, with very limited training and support from Software is absolutely incredible, and I certainly applaud them on the magnitude of their work. So with that, we'd love to show you guys a little bit about what RoadEng can do. The plan here is it's going to be a high-level workflow. I'm going to pass it over to my colleague, Matt, and he is going to show you, a little bit about bringing in some total station data. This data in particular is from a project in Sierra Leone. We're going to show you how to build a terrain model, do some alignment creation, get some volumes, and create output. And hopefully through this, you can help to see some of the differences that RoadEng makes, in particular, the ease of use. So please, as we transition over to Matt, don't pay attention to the individual steps he's doing. This is really focused on just giving you a high-level overview of how the software works. So Matt,
awesome.
Enough for me. Over to you.
Thank you for the intro. And I get to do the fun part of clicking around, showing off what we've got. So I'll run through the software. Now, our software is modular. So we've got a location module where we're going to do our kind of classic corridor design. And we've got terrain module, and that's where we build out our topo surface. So I'm going to start in the terrain module, and we're going to bring in our survey data. So a new, starting entirely from scratch project. We're going to click Insert File. I'm going to grab my survey data. And just before I bring it in, a little context for what we're dealing with. Of course, total station or RTK data, pretty standard format is that CSV where we've got a point number, some coordinates, and a code. So we're going to bring that in here. And one really nice aspect of working with that conventional survey data in our software is we can build out what we call an IOP. And with that, we just set it up to match our design standards so we don't have to do a lot of clicking around after. So I'm going to select this one that I've built to match my survey standards, my X coordinates, the third column, my Y coordinates, the second column. I've got my codes. And those codes, I'm telling it that, well, anything that is coded as C is going to be brought in as a blue line. We can set our projection. So if it's georeference, we know exactly where we're at in the world, and we can hit OK. So we'll zoom in here, and we can see, well, instead of just having a bunch of points, the lines are already connected. And if we go over to our 3D view, we can zoom in a bit here, and we see that, well, that data is in fact 3D data. And from that 3D data, we can go over here to terrain modeling, and we can create our tin surface. So we can zoom in, we can see what we're dealing with. If we wanted to change something, we could modify our line work. If we had a line that wasn't properly connected, maybe it got miscoded, we could tweak that. But here I'm happy with what I have. And our design in this example is an upgrade to an existing road. And we're going to try and use that initial, the surveyed alignment as our starting point. So we're going to keep the road in line with that, and just an upgrade. Now with this, and this is entirely optional, but oftentimes it's nice to have a little extra context rather than just the dots and lines of where we're at. So since we've got georeferenced survey data, we can connect to a web map tile service, and we can bring in imagery. So I'm using Google in this case, but we can connect to other web map tile services. And we're going to download that image locally, and that way we can see where we're at as we design.
It's worth mentioning, this is one of those few moments that the software is actually accessing the internet. So everything else that Matt's doing here in the software is being done directly on his desktop or laptop.
And this is an optional step too, just adds a little context. So if access to reliable internet is not available at the time, you can continue along just running off the survey data itself. So we've got, I guess where we're at, we've brought in our topo data. We've got all our lines that we want connected. We've turned that into a surface. We even grabbed an ortho image for the background, and I'm going to save this now. We're going to just call it topo, and we're going to switch over into more of the design realm. So for that, we're going to use this other module called location. We're going to reference that topo that we've just saved. We could draw in our alignment entirely from scratch, kind of tracing that center line that we were given. Or we can reference it. Since we want to follow that center line, we're going to set our initial alignment to be equal to it. And we can see, well, we've got our 3D view, we've got our cross-section view, our plan view. If we want to see that ortho that we downloaded, we can add that in. We've got our profile view, and I'm going to start really diving into the figuring out our geometry. Now, for this, we could add in a curve manually for all these curves that we're going to be dealing with along our design. Or we can use a tool called polyline to alignment, which is going to take this polyline, without curves, and we're going to apply the curves to it. So we'll come in here. Now this road, I want to have a minimum turning radius of 250 meters. And I'm going to give it a little bit of wiggle room to deviate from that. So I'm going to keep it simple. So right now, instead of manually tracing the center line and adding in curves, or taking that initial center line and removing IPs, the software is doing a lot of the tedious work for me. And this is one of those things where, well, it's not instantaneous, but it's very fast for what it's doing. So we've got all our curves added in here. If we click along our alignment, we see that the super elevation's being applied for us in those curves. And we can customize that to match whatever standards we like, but I'm using AASHTO standards here. And next we will start to give thought to other geometry. So the cross-section geometry is an important one. We've got that here. Now I've got my cross-section templates. And these, we can pull them around, see how they behave. We can expand the templates themselves. We can change our parameters if we want. So right now I've got a 7-meter wide paved surface. If I wanted to make that, say 9, I could go 4.5 on one side, and we can see those changes in real time. So same with all these other components. And if we wanted to do something that was, well, a little more unusual, we could go onto the library and bring in, well, something like a wall component might be a good example, where it's really easy to design these more complex geometries as well. But for this one, I'm happy with my default geometry, so I'm going to hit cancel and we're going to run with that. Now, the next kind of consideration in our project is horizontally, we're following that existing road. But this road needs significant upgrades. It's basically a full rebuild. It's got a weak prism with very little drainage. And we've got some, well, kind of uncomfortable grades and vertical curves in there. So we're going to design our vertical. So we could come in here. Let's go to the start of our road here so we can see. We could add in our curves. So I could say, well, I want to have my road way up here. We can see in the 3D. And we could run along with that. But I am not going to do it by hand. Instead, I'm going to use something about our software that really makes us special, and that's our kind of the optimization tools. So for this one, rather than choosing my vertical alignment by hand, I'm going to optimize it. So I'm going to go over here. I'm going to tell the software, well, I want to have max grades of 12%. I want to have my K values of crests of 11, sags of 12. If there's anywhere I want my road to be at a certain elevation, I can add that in as a control point. The software is going to look at earthworks cost as it does its optimization. So I've got my unit rates for the material I expect to encounter populated here, and I can change those unit rates by material. It's also accounting for my haul cost. I can click process, and we can let this thing think. So again, software's going to take a moment to think. And instead of going through the monotony of the guess and test method of moving around IPs and whatnot, the software is using a bunch of math, considering the design constraints that you've put in there and finding the cheapest solution. So it's converging. And here we are. We have a vertical alignment that's adhering to our design constraints. We can zoom out here a little bit. Actually, we'll zoom out a lot. So we can see there's a few spots where we've got some notable cuts and fills. So my mass haul is tracking my surplus and deficits of material. If I zoom in here, I can see, okay, that makes sense. We're filling through this low point, and we're generating the cut for that low point right here on the sides. If I'm curious how much cut and fill I'm actually doing on the project, like total volumes rather than surplus, I can pop open a data table. I can see, well, I'm cutting about 24,000 cubic meters. I'm filling about 24,000 cubic meters. And my surfacing materials, so that aggregate, I've got that noted here as well. With that, based off the costs that I've given the software, I can see my earthworks are estimated at $390,000. And we can add in culverts anywhere that we would like to add culverts. So I'll add a pipe there and we can see it. Now, with this, if I'm happy with my design and I'm ready to put that into a design package, a deliverable, I can go over to our multi-plot page and we could add in individual views, build out our document exactly how we want. Or once we've done it once, we can save that and use it as a template for future use. So I've got a multi-plot book template here. So I've got my title page set up. I can modify it however I'd like. And I've got my plan over profile. So I've got that set up again, exactly how I like to show what I like without having to do a bunch of mucking around. And then I've got my cross-section chapter as well. So, and just a quick recap of where we're at in the grand scheme of things. We started out in terrain, we brought in our survey data, we modeled a surface out of it, we saved that terrain file, we came over to location, we, well, set up our initial alignment, we turned that initial alignment into one that has proper curves and tangents. We set up our cross-section geometry to be what we'd like, and then we optimized our vertical alignment, added in culverts, and now we've got our polished package done and ready to go. Now, if we want to, aside from just having the paper plans, if we want to export this out for construction staking or sharing in other digital formats, we can hit File, Save As, and we can save that out in any number of industry standard formats like Land XML, DWG, etc. And the last thing I should mention here, since we are using line work that is from the survey, just want to reiterate, the software is fast, easy to make adjustments. So if we want to pull our curve over here, it's just a matter of pulling it over and we can see the changes in real time. And in this case, our mass haul changes to reflect that. So, yeah, fast, dynamic tool that's easy to use. So we ran through that in a few minutes. And with that, I'll hand it back to Erin.
Awesome, thanks, Matt. Yeah, so that's kind of our first demonstration, a quick look at RoadEng with a total station project. And hopefully you were able to kind of get a sense of the ease of the workflow and the interactivity and how it was dynamically allowing you to edit and work with your designs. So we're going to move into our second software demo. And in this case, we're going to be working with some larger resolution data. This is kind of analogous to if you were working with, say, LiDAR data, DEM data, or perhaps maybe you have access to drone data. So in this case, we're going to hopefully show you a little bit about how we can handle those large resolution data sets. As well, we're going to have a little bit of fun with another sort of key feature / tool of ours, which is an AI tool, which when you're creating a greenfield road or corridor project, can actually tell you where to put the road, give you some sort of optimized alignment locations. We're seeing this most commonly used for things like renewable energy projects, if you need to connect roads between turbines, as well for greenfield access road projects, really suitable. So with that, I am going to pass it back to Matt. We're going to go into the software and take a look at a second demonstration using a second type of data.
All right, so back doing the in-software side of things. So for this one, there's some similarities. We're going to start in terrain again. And I'm going to bring in my LiDAR data. So this one, I've got the DEM data here. We're going to bring that in. So I've got 5.6 million points right now in this file. But just like when we were working with total station data, we want to turn those points into a surface. I'm not going to use contours this time. So big thing is that we get the surface.
And while we're waiting for that very quick calculation to solve, a quick reminder to all the folks in the live presentation, you can definitely ask questions, engage with us. There's a couple there in the chat, but yeah, please type your questions and we'll tackle them at the end of the presentation.
Yeah. And so I calculated our tin surface. So here we can see, rather than just having that surveyed strip of topo, we've got basically a whole landscape with a lot of stuff going on. Now this example project that we're going to deal with, I've got this existing road here, and it's crossing some relatively complex terrain. Problem here is that as it's wiggling through these hills and avoiding these gullied creeks, users have to slow down too much. So if we want to upgrade this for a faster road, we totally can. Now, if we want to let well, even if we're doing this manually, it's nice to know if you have any low spots where there's going to be ponding water, where your flow paths are going to concentrate and create streams. So if we want to visualize that information quickly, we can use our hydrology tools. So we'll come into streams and ponds, and we'll run this. And just a note, the reason I didn't do that in the total station example is usually if there's a stream, it gets surveyed, so we don't really have to worry about redelineating it ourselves. So we've got streams. We can see a few spots where there's likely to be some ponding water. And, well, we could also delineate anywhere that we don't want to go. So if we had, well, say all these gullied creeks, they look like we've got some terrain stability issues. We could delineate those. Or if we had that information already, we could bring in that vector data from any number of formats. So here I've got it in a shapefile. Now for this, I'm going to tell the software I want to go from let's go from, say, here all the way to here. Since our horizontal curves are the issue, I don't want to follow that initial alignment. I want to realign it to match my design specs. So I'm going to go to our optimization tab in Terrain. We're going to click Path Explorer AI, and we're going to configure this so it finds the best route from there to there, given our constraints. So I want to have a 50-kilometer-hour road, so I'm going to go with a minimum horizontal radius of 100. I want to have max grades of 12. And, well, if I want to take into account that, well, those streams and ponding areas might cost a bit more, I can add in construction zones. So I'm going to tell the software that anywhere I'm crossing a stream, I'm going to say it costs $5,000. Now, I can also tell it that if there's anywhere that I don't want the software to go, I can use a no-go feature. So in this case, I've got that stable area delineated. I don't want to cross that line. So I'm going to use a no-go polyline. And so here I've hemmed in the software, so it's not going to cross that, and it knows that my streams cost more than just dealing with the excavation and filling of material. And lastly, here, if I want to control my approach directions, so make sure it's pointed in a specific direction, we can do that. And yeah, we'll hit OK. We'll let this thing think. And again, it's figuring out a really big problem. For what it's figuring out, it's doing it extremely fast. So we'll let this think, and we're going to see that the software, what it's displaying here is going to change a bit. So it was saying no solutions found yet. So now it's saying it's found 5 paths, but it's still looking for better alternatives. So it's going to keep searching and checking millions and millions of different configurations here for how we can get from point A to point B until it either says it's done searching and or it says it's unlikely to improve. So here it says it's done searching, and there we are. We can see our alignments. Now with this, there's a couple things worth noting. The software, I told it to look for 5 different paths. So if we had a bunch of really spatially diverse solutions, it'll give you those spatially diverse solutions provided that they aren't outrageously expensive. So all solutions are going to be within 15% of the cheapest. But here, well, it's pretty constrained. So all these different solutions are fairly close to one another. And that's just a product of we're avoiding all this steep, gnarly terrain here. We're avoiding creeks and trying to minimize our cuts and fills. Now, of these 5 solutions that we have, if we want to see which one's cheapest, we can select feature and we can see, okay, that Path Explorer feature, the number after is our cost. So that one is our cheapest option. Once again, we can hit save. I'll save this out as a topo, and to take that line on the map and turn it into a proper road geometry with cross sections and all that good stuff. Once again, we go back over to location. We reference that topo. We can run that polyline to alignment tool here. And we can run our vertical optimization. And there we are. We've got our design. We're adhering to our constraints. We can see our cuts and fills. We can come over here. We can see we're shorter road, but gnarlier terrain. We're moving about 40,000 cubic meters of material. We could take that over into multi-plot, add in our pipes, but we've essentially figured out this full 3D model that adheres to our design constraints and minimizes construction costs, all again within a matter of minutes. So with that, I'll hand it back to Erin.
Awesome, thank you, Matt. And so we've just very, very quickly gone through two different software demonstrations and taken a look at 2 different types of data sets. And with that, I think it's also worth noting that there are more functions and we can actually go deeper. So we've kind of gone through a core workflow essentially for both total station data for a road project as well as a greenfield project leveraging a higher resolution data set. But more advanced and deeper functions are possible with the software. And I know we talked about complexity being one of the barriers to a design software. Well, hopefully, yes, the ability to do some more complex projects is certainly possible within a simpler software and simpler interface. In particular, culvert projects, site design, as well as including some other more complicated cross sections. And the 4th picture here shown is that of a cross section that includes a wall, and that is just simply attached to the cross section, and the wall is created as you apply the cross section template. So a lot of flexibility, but a lot more complexity is possible, all within the same software platform. And with that, I do think we've got a little bit of time for some questions. So for the folks in the audience, if you have some questions, certainly, yeah, this is a great opportunity. Type them into the chat, and we will now go into that final part of our webinar agenda, which really is the Q&A side. So Matt, I'm going to send the first question your way, which is, let me read it properly here. Do you have connectivity to global topo data. Are we able to download that in the software?
Yeah, I guess the short answer is yeah, I can take the screen here. And
yeah, I was gonna say, I'll make you the presenter again. Great question.
Yes, so we totally can. And of course, this example was a full-on LiDAR data set. So not all remote sense surfaces are kind of the same quality or from the same source. So just, and I'll use it as this question as an excuse to talk a little bit more. But yeah, we work with our clients work with drone data, fixed wing LiDAR data, satellite DEM data, and with that, there's kind of a whole spectrum of accuracy and costs associated with that. So there's some really detailed satellite DEM data that you can get, and usually that comes for a fee, but it's still much cheaper than a full LiDAR acquisition of the area. But there's lower resolution satellite DEM data available globally. So the SRTM data set's one example, and we connect to something very similar to that in terrain. So I'm going to just go on here. All right, so I've just got a KMZ that I'm going to bring in here for a frame of reference so I don't grab the wrong spot. Oh, so I guess I have a frame of reference for where I'm at. So here we are. I'm going to switch this over to be map tiler. And we'll hit save. And I think I had my projection set to not be in the area that I was at there last time. So we're bringing in our data. And here we'll just turn off those points again. We'll click terrain modeling. I'm not going to worry about my contours. And there we are. So yeah, we've got a surface. Now we've got a surface for an absolutely massive area here. Now it's not as detailed as that LiDAR surface that I have, but if we're doing preliminary planning or checking to see if grades work, we can just connect to that live maps provider in this guy here. So connect to a map tiler, terrain, and download it, and we've got DEM data available for anywhere in the world.
Okay, Matt, we've got another question that's kind of in the same space, so I'll leave the screen with you. So this next question is, first off, they're saying thank you for the session. You're very welcome. But they would like to know if the software can handle large GIS data sets.
Yeah. So with that, and I don't have a big data set to pull from myself at the moment, but well, in this example, I brought in a KMZ. In this example here, the line work that I brought in was from a shape file. So yeah, those GIS formats, we ingest them easily. And yeah, there's all sorts of times where you want to use that data from another source. So it really is just a matter of clicking insert file, and we can see, well, there's a bunch of supported formats just with the default settings. GIS, though, shape is going to be the big one. You can bring in imagery data as common image formats, but TIFF is probably the most common one. So could be orthos, could be something that you've got mapped as, yeah, just a graphic for something else. Yeah, so all sorts of functionality, and outside of just the GIS world, if you have line work for maybe legal limits or something like that in DWG or DGN, we can bring that in too. So no problems with that.
Yeah, and then in terms of like the large data set side of things, it's probably worth noting the software itself. We recommend keeping the number of modeled points under 10 million. So if you're bringing in some data from, say, for example, ARC that has elevations, bringing it in as a data set, likely through something like a GeoTIFF, but we would encourage you to try and make sure that the end data that you end up working with for your project is below around 10 million, depending on your hardware. So there's a whole bunch of tools inside the software to allow you to control the area that you've brought in, its size, as well as the number of points through selective thinning. So there's a few different thinning methods, but this dialog here is great. It allows you to add excluded regions so that you can use features, for example, like a polygon to denote your area of interest, and then you can remove all the other points around it. So with the software, really important, just to keep it moving as fast and interactively as you've been seeing throughout this demonstration today, leveraging the thinning tools. But yes, Matt's working with about 5.7 million. That's a really nice number for his computer, which is just a typical business grade laptop to be able to operate with. Okay, we've got 2 more questions that I think we've got time for. Let's do the easier one first, which is, can I get a copy of the recording after the presentation, presumably through our emails? And the answer to that is yes, absolutely. We will be sharing the presentation link out to everyone who registered for today's webinar. We'll also be posting the session to Softree's YouTube channel. And if you haven't been there before, our YouTube channel has a fantastic collection of different videos, whether that is a specific little how-to tip or something, a more in-depth workflow. We've got hundreds of videos there available to help our clients learn and work with the software. Okay, the last question of the webinar with 1 minute to go. Nat, this is coming over to you as well. How does the software handle unsuitable material? We want to exclude some of our ground from the construction. Hopefully,
All right.
yeah.
Yep. All right. So if you're dealing with material that you are maybe excavating, but you don't want to use as fill in your embankment, the software is really at the forefront of dealing with materials and extra complexity around suitability. The most common strategy for dealing with, or I guess the most common unsuitable material, is just dealing with organics. So often on greenfield projects, there'll be a layer of organics that you want to remove. For that, we can go into site prep. We can say we want to remove 20 cents of organics. We can say, well, how wide of a swath do we want to remove that? So here I'm just telling the software I want to remove it right to our slope stake edges. We can hit OK. We can hit OK. And now we see that that material, and I'll just hatch my cut, is not counted as subgrade material. So with this, that's the wrong data table. My stripping volume is accounted for now. The other side of it would be, well, if we added in ground types. Oh, and I don't have a great unsuitable example right here, but I'll say from 975 to 1460, we've got shallow rock. So I'm going to say we've got overburden over that solid rock material. We'll say that the rock is 1 meter deep. And if you had a more detailed surface, we could use that more detailed surface for your rock layer. But the first thing for unsuitable materials is accounting for the fact that different materials might be, well, where the different materials are. So we've told it that rock is there. If we wanted to tell the software that that rock wasn't suitable, so I mean, a lot of the time rock is a desirable fill material, but maybe we're dealing with acid rock or something like that. Well, we could tell the software that the solid rock material isn't suitable. We can tell the software that everything else is Q2 or better. And we can tell the software that my fill material has to be quality 2 or better. So we're telling the software that the rock is not up to snuff. And well, we could re-optimize this and the software would take that into account. We could also add in what we call the OptiHaul side of things. And we can see that we've got spoil. So all that rock we're going to take and we're going to dispose of it. And if we even expand this, we do a little recost. And just a note too, as I go through this in a little bit more detail, this is one of the kind of the deeper ends of things. We can see that we've got a deficit of material. And we're saying that the rock, the 15,000 cubes of solid rock, is extra and we need to dispose of it. So we could add in a borrow site to account for that haul distance or a spoil site, and away we go. So we could set up all these different ground type configurations. I'm going to add a location where we can dispose of the undesirable rock material. So we're going to add a waste site in here. And we can rerun our optimization and it'll figure out the best vertical alignment considering all these extra complexities that we've added into the software. But yeah, again, it's not something that you have to do on every project, but if you do have these more complex needs, the software is, again, at the forefront of this side of things. I hope I didn't go too deep there, but yeah, super easy to add complexity.
Awesome. Well, do you know, while you were doing that, a couple other questions that are relatively simple to answer came in. So I'm going to steal the screen back if that's all right, Matt. Yeah. Okay, so the next question is, to request a trial, do you need to have raw survey data? Great question. First, I want to start by answering that if you are interested in getting a trial, we actually dropped a QR code here. You should be able to scan that with your phone. It actually works against a screen, believe it or not. So you can actually get access to a free 3-week trial. Of note, the one particular feature that we did include in our second demonstration, Path Explorer, is actually excluded from trials. But for that, happy to book a custom demonstration and talk you through it. But for that trial, no, you do not need to have your own raw survey data. There are some example data sets that do come with the software. And you're certainly welcome to contact us and we can supply another one for practice as well as some online training tools to help work with it. But if you do happen to have your own raw survey data, most definitely you can load that up into the trial version. And if you need help, that is definitely something that our team helps with all the time. So we can help you figure out how to import it and get you started. Yeah, so that was the question about the trial. The other question while we're on this slide as well, which is how do we get in touch with KeyCam? We would like to arrange a presentation. And again, we've got another QR code here on the screen. You can scan that and Bonnie and his team would be happy to arrange a local demonstration for you. Yeah.
In addition to that, you can send an email to info@keycamtechnologies.com. Definitely somebody will get across to you.
Yeah, and we can certainly put that as well. We typically, following a webinar, also send out an email with a video recording link. So we'll put that in the email as well, making it a little bit easier to, yeah, you do some of these next steps. Okay, so the next question, and I hate to leave such an easy to answer question hanging, so we're going to go for it, which is, can you quickly explain the different modules of SoftTree? And yes, kind of confusing initially because we're a program that has basically 2 little programs within it, or arguably 3 actually, if you include another one that's built for forestry, but 2 key modules within the software. And by keeping them separate, we're able to actually simplify the user experience. So the first module that we saw Matt work with in both of his demonstrations today was the terrain module. And this is our module for working with surfaces, essentially. So here we can import our topographic data, whether that's total station data, LiDAR, GPS. This is where we build our original ground surface. It's also the place where he was able to do his initial optimization using Path Explorer. The terrain module can also be used for any other type of non-linear design. And examples of this might be if you had a stockpile and you wanted to calculate the volumes. We would do that here in the terrain module, or other site design elements. If you are making one of the ponds that I described that in that case study that I presented from the local government engineering group department, I should say, in Bangladesh, they designed ponds, and those ponds are designed here in the terrain module. The other key module of the software is the location module. And this is where Matt, in both of his demonstrations, tackled that 3D road design. And again, by keeping it separate from the terrain module, we're able to reduce the number of buttons and the amount of complexity that the software presents our users with. So here we can create the horizontal vertical alignments and do some of our costing and optimization for the earthworks further. And as shown here on the screen too, we can include the culverts. So that's our location module. The last question, and I'll just pop this one up to leave it on with, which is, can this software replace ArcGIS? And on my answer to that, and I think it would vary by person, but is no. I would certainly recommend, GIS software has its own place and its own purpose. And although some of our functionality kind of touches into that GIS type space, our primary purpose is road design. And ArcGIS is really, really excellent, as well as QGIS for keeping your data and helping you, to have some spatial information really easily accessible. And with that, everyone, thank you so much. Thank you for your time. Bonnie, thank you so much for being here with us today. And Matt, of course, thank you for your webinars. They're always great. If anyone else has any other questions, we're happy to answer them. You can reach out to us at our softtree.com website or get in touch with KeyCam, and we're happy to help you out. With that, have a wonderful rest of your day, everybody.
Thank you so much, Erin. Thanks, Matt. And thank you, audience. Affordability of the software is there, ease of use is there, local support is there, and empowerment in terms of training. Be rest assured. Thank you very much.
Have an awesome day, guys. See you in the next one.